Welcome to the People of AI podcast, showcasing inspiring people with interesting stories in the field of artificial intelligence. I'm Ashley Oldacre. Let's jump right in. This podcast is sponsored by Google. Any remarks made by the speakers are their own and are not endorsed by Google. Hello, Ashley here. I'm thrilled to introduce you to our very special guest today, Kathleen Kenealy. Kathleen is a software engineer at Google DeepMind, where she does research on the next generation of large language models, LLMs for short. And previously, she conducted research on AI-based chatbots as a grad student at Stanford University. She joined Google Brain after graduating and has since worked on large-scale training infrastructure, researched novel techniques for deep learning, and developed open large language model development. Welcome, Kathleen.
Thank you. I'm so happy to be here.
Very excited for you to join, especially right now with all of the amazing new things that are coming out from Google and your work on them. And so we're very excited to dig into that. But before that, we start with every guest the same way. I would love for you to tell us a little bit about yourself. Take us as far back as you like. Tell us your story.
Yeah, absolutely. I'll give you the long version.
Yeah, that's what we're here for. Definitely.
Yeah. So growing up, I was always a math kid, always loved sort of the solving puzzles and the problem solving of math. And I went to an all-girls middle and high school where I was very fortunate to be surrounded by lots of brilliant women who loved STEM. And so I sort of dove headfirst into as much math as I possibly could, did a little bit of coding and programming. So when I got to college, I went to Stanford. I had absolutely no idea what I wanted to do. I knew that I loved mathematics. I was also a theater kid. So I double majored in math and in theater for a really long time while I was in undergrad. And was very fortunate that I got an internship at a very small startup early in my college career. I think I was the 5th person at the company.
Wow.
And it happened to be the summer that Google released TensorFlow. And so the CEO of the company said, "We're hearing a lot about this machine learning thing. Google just released these amazing products. Go figure out what that is and tell us if we should be doing that." And I really had a light bulb moment playing around with TensorFlow for the first time. I basically saw that this technology was mathematics about understanding people. And there was so much creativity in figuring out how to apply this technology and so much really heavy mathematics at the core of it that I sort of fell in love with it immediately.
Wow.
Changed my major to computer science, specializing in artificial intelligence, and didn't look back. And
That's
in
incredible.
particular, I always was fascinated by machine learning focusing on language and text. I think through theater, I'd really fallen in love with language and how it reveals really interesting things about who we are as people and as communities. So I was always super interested in how we could use technology to gain that same level of understanding about other people and how we could use it to bring communities together. So when I was at Stanford, I focused on novel machine learning techniques for text-based applications. Worked a little bit with chatbots way back in the day. And I joined Google Brain right after graduating, and I've worked on a lot of cool projects with the amazing teams there. But my focus for the last year and a half has been on open models and on the open source community. I've been the beneficiary of a lot of Google's incredible history with open source. And so it's always been something I've been really passionate about, and I'm excited.
This is quite an extraordinary journey that you've had. So
Thank you.
So, I mean, not to sort of jump in on stereotypes here, but you typically have students who are interested in STEM and students who are interested in the arts, and very rarely do they kind of cross over. And I would love to go back and understand like this interest of having both. I mean, I'm really curious as to how you combine those two and sort of the bridge of the interest between the math and the theater arts?
Oh, what a great question. I think, in a way, that was something that didn't feel super foreign to me because my family is full both of artists and of sort of math aficionados. So I have a lot of family members that do both or are very interested in both. So like I said, I always loved math as a kid. I just always wanted to do a puzzle and loved solving problems like that.
Solving problems and sort of, getting to but what was so attractive about solving like the math problems versus solving like, a personal problem or like a story or I don't know, like what's sort of.
It's very theoretical. It's very like math is something that I think is very beautiful. One of my favorite teachers of all time, a math teacher, we very rarely ever looked at a textbook. Instead, when we wanted to learn about math, he would point us to something in nature that demonstrated the mathematical concept that we were talking about.
Oh, wow, like what?
So when we were talking about, sine waves and what is a sine wave, and they sort of go like this, he brought a guitar to school every day that week, and we would watch slow motion videos of each other playing the guitar to see how the strings of the guitar make a sine wave and how that's correlated with sound. Or we learned about different patterns and the Pythagorean numbers are a pattern that we see often in mathematics. And he brought giant piles of pine cones to school to show us how pine cones demonstrate the Pythagorean spiral. So I always thought that there was something so beautiful about mathematics, that you can see it everywhere if you're willing to just look for it. And it's not something that we create, but it's something that we discover. It already exists in the natural order of the world. So I always felt like when you're solving mathematical problems, you are solving the problems of the world and of the natural world. So I just thought it was very beautiful and logical, and something that helped uncover how the world works at both these tiny scales and these humongous scales, both how a pine cone is made and how the planets orbit each other in the universe. So I thought that was really wonderful and sort of amazing, and I was very awestruck by that.
Beautiful connection and view and approach to math, and I wish I'd had that as a kid, because I'm allergic to math. I'm so terrible at it, and I think it's because it was sort of these problems that were presented to me that was a constant reminder of what I was doing wrong. Because you're solving an equation, it's like if you don't get the exact right answer, then it's wrong, and so that level of precision felt so stifling, and so the answer that you just gave about how when you connect math to the larger, to explaining things around you, and it's used as a tool to understand the world around you. I wish I'd known. I wish I'd had that perspective back in primary school, because I think it would have helped so much understand the relationship of why, and maybe I think also then help me get so anyway, that's just my personal view. But I think I think math is probably taught in a certain anyways. There's just. Yeah,
absolutely. I think people are always surprised to hear the combination of math and theater as two of my sort of primary academic interests. But I think it goes towards exactly the point that you just said, that to me, math is very creative, and the sort of programming and technology development that we do now is so creative. We're looking at trying to solve problems that we've never seen before, and so you have to be willing to do really creative, wild things to try to solve them. So to me, they always felt very similar, because they're both this sort of, you have to fearlessly explore different techniques to solve a problem. You have to be real creative
Yeah.
in both pursuits.
Right. But I feel like when you're representing, because theater is about sort of representing stories and other
Yeah.
people, I feel like there's so much more ambiguity and navigation to a person. And so if you say, it's like if you say something, it could be interpreted so many different kinds of ways. And there's that flexibility, that sort of, that ambiguity that allows for more play and more different solutions. So you can kind of get to the same conclusion, but by different approaches. Whereas math feels like it feels like the opposite. It feels like there's one answer and you have to use this one approach in order to get to that one answer.
Oh, that's interesting that you say that, because I feel almost the opposite about math.
Oh, say more.
That there's so many different ways you could arrive to the same conclusion. And especially working in research now, there's, if we take large model training as an example, the goal is we want to build the best option out there. There's so many different avenues that we could take to do that. And there's so many components to this technology that changing a single tiny sort of knob that we, of all of the knobs we could configure, if you change just one, it could have a huge impact.
Yeah. Right.
So of the thousands of knobs we could turn, everybody plays around with different ones. And so there is an aspect of it that does feel like play to me, in that we're always trying to figure out what's the right combination of things to change.
Right.
What should we try? The answer changes every day. Right. And so there's a million different ways to get to the same outcome and the same answer. And to be fair, when we're looking at algebra, there's some fewer ways to get to the same answer. But I think, the farther and farther you go, the more creative you have to be, the more willing you have to be to explore different options. So to me, it feels very playful, because it's not obvious to us what the right answer is, what the right problem-solving technique is. So we get to try lots of different things, and we're not always right. We fail a lot of times, and you just have to be willing to try again the next day.
That's fascinating. Such an interesting perspective. I'd never considered this, and I'm learning a ton. So this is great. So your love of math started as a child, and it sounded like it was really cultivated at school as well, in the learning environment. And how did you get interested in theater?
Oh, another great question. I also I became interested in theater at a very early age. It just so happened that my elementary school required every kindergarten class take a theater class. So theater was mandatory starting in kindergarten. And I fell in love with it right away. It's exactly what you just described I think in school, there's a lot of ways that we need to be very precise and very rigid, and we need to get the right answer, and we have specific things we need to learn. And theater is the opposite of that. It's about failing spectacularly.
Yes.
Because there's actually no such thing as failing.
Exactly.
Just being present and being engaged is so interesting in theater. And so it was so playful and so fun and so collaborative. That was really the thing that I loved the most about theater, was creating something with a team of people who were passionate and excited about what we were making. And so I just never stopped. And it ended up being this incredible balance of activities to work on.
It sounds like it.
That theater allowed this opportunity to be playful and silly and goofy. And to me, it's also the ultimate exercise in empathy. Like you just said, it's all about learning as much as you can about somebody else
and putting yourself in their mindset.
Exactly. So I just think it's such an interesting way to learn about the world and explore other lives and understand even more about who we are as humans. So it started again from the very get-go, and I just never stopped.
That is so awesome. That's so
Thank
awesome.
you.
Yeah, no, and I think what's fascinating about this evolution of sort of machines and machine learning and artificial intelligence is that it's almost becoming another player in the field of humanity. And so connecting, the sort of the language and the, understanding the computer and sort of, I can see now a little bit more the intersection of how musical theater and language and math are sort of combining into being very valuable in developing artificial intelligence. Would you say?
Absolutely. I think working on AI is in some ways an exploration of humanity and what it means to be human, what it means to be intelligent, what role AI should play and how it interacts with humanity. And so that element, I think, is part of what made me interested in theater to begin with. So it's interesting to see those same questions coming into play now with AI.
Oh, that's fascinating. That's fascinating. So, okay, so many things to cover. So let's continue on the sort of the chronological journey. So I think I would love to know also about the impact of going to an all-girls school on your education, because I think there is, I don't think this is a secret. It's well known that, there are a few women in tech, there are a few women in STEM. Yeah. And you're incredible at what you're doing and the things that you're creating, and you're not restricted. You're not inhibited by the knowledge that you have. And I find that to be such an amazing quality and an amazing skill. And I want to dig deeper into how that's come up for you and how that's been cultivated. And one of the first things I can think of is wanting to know a little bit more about the impact of going to an all-girls school, and if that sort of was a big part of your development and sort of the confidence that you have in your abilities as an engineer, as a professional, as a person.
Absolutely. I cannot overstate the impact that had on me, especially as a woman in tech. I think truly one of the greatest blessings of my life was being able to attend an all-girls school from grades 6 through 12. Because when I was growing up and learning that I was passionate about STEM, I was in rooms that were 100% women. Mm-hmm. So it didn't ever occur to me that it was abnormal to see women in STEM-related fields, because everyone I knew who was interested in STEM was a woman. Mm-hmm. So by the time I got to college and frankly was, one of maybe a handful of women in the room, I was able to say, it's not abnormal that I'm here. This situation is abnormal. The situation is what needs to be corrected, not the other way around, because I had this incredible experience of being surrounded by women who loved STEM. So I felt confident that I deserved to be in the room.
Right.
Because
it wasn't a personal thing.
Exactly.
It wasn't personal, I'm not smart. It was, okay, I've had a different exposure and a different confidence building and so you weren't putting your abilities into question because of the demographic of the classroom.
Absolutely. And to be honest, there were absolutely many days where I did question if it was me, and there was doubt and fear. And so the other aspect of having attended that all-girls school is that I had this incredible community of brilliant, powerful women who I could rely on. And I had this incredible support network between them, between my family and friends, that on the days that I said, maybe it's me, maybe I'm not supposed to be here, I was able to rely on this incredible community to sort of bolster me and say, no, it's okay to be here. And I got to Google, and I had my entire reporting chain all the way up to Sundar was women. Wow. And I saw these incredible female leaders at every level. And they created, sort of environments and communities where I felt supported. So there were a lot of days where there was a lot of fear and doubt. And I was incredibly lucky to be able to rely on so many of the people who came before me, the people who were having the same struggles as me. And that community was really unbelievably impactful.
Yeah. Yeah. And I'm sure you're still in touch with those community members today.
Oh, absolutely. Absolutely. Those women are still the women that I talk to every day.
That's amazing.
Yeah.
That's amazing. So that community has been really impactful. And I've also noticed that at Google, I'm very fortunate also to be surrounded by a lot of, I feel like it's not just a lot of women who have been around that I've been able to see, but I feel like that the male mentors that I've had have also been very, very supportive too. And it's sort of, I mean, just all this to say that, it's been a pleasure working here at Google, because I feel like that it's not perfect. No place is perfect. No. But I have to say that I feel more at ease as a woman at Google than I have anywhere else.
Yeah, I think that this is an incredibly unique place to be. And what I mean by that is I've never encountered such generous collaborators and leaders as I have at Google. I think people are generous with their time and with their energy and with their knowledge. And everyone at all levels is invested in learning. So I feel very supported in my own learning and growth. And I know that there's always people that I can turn to support me. And I think that that's really incredible to have that level of support and generosity everywhere I go within Google. Yeah. That's part of the reason why I decided I wanted to come to Google, and part of the reason that I love working at Google still after all these years.
So I would love to know about your journey kind of into Google. And so it sounded like you had an internship at a startup prior to joining Google, and that's when you talked about discovering TensorFlow. Yeah. And if you want to talk more about that, because that discovery of like, oh, TensorFlow is amazing, and it sort of is bridging all the things that you were looking for. Like, say more about that. I would love to.
Oh, absolutely. So I think, we just talked about that I sort of loved solving technical problems and also was very interested in learning more about other people and our communities and how we interact with each other. And so I had a lot of questions that I was interested in regards to technical problems and questions with regards to understanding how we interact with each other, communities, and things like that. And I had never really seen those things those questions interact super clearly. And I will never forget the day that the CEO of this startup had asked me to look into TensorFlow and said,
quick, what is TensorFlow?
Oh, great question. TensorFlow is a machine learning framework and code base that Google released. I want to say it was in 2015, a while ago. And it was one of the first machine learning code bases made available to the public. So machine learning involves a lot of very complicated calculus with matrices in many, many dimensions. And it's very difficult to ensure that you code all of those mathematical operations correctly. It previously required a lot of expertise, both in programming and in very high-level mathematics. So when TensorFlow was released, it was revolutionary because it was a code base that already had written out all of those complex mathematical operations. So you could just sort of piece them together and stack them in interesting ways to accomplish the machine learning goals that you had for your code.
Oh, wow.
So it was revolutionary in that it removed the requirement for this very high level mathematical expertise and made machine learning programming accessible to huge populations who it wouldn't have been accessible to before. So when TensorFlow was released, I was in undergrad. I did not have that very, very high level of mathematical expertise that was required. So it enabled me to explore machine learning for the first time. And, it requires you have a lot of data that you're able to look at and inspect with your machine learning code. So the CEO of this startup said, we have all of this data. Now we have this TensorFlow. Figure out if those things can work well together. And I'll never forget the day that I first got something working in TensorFlow. And we were able to, basically our data was looking at a bunch of different ads that had been run for our company. And we weren't really sure which ones were working and which ones weren't. And so we used TensorFlow to predict the level of engagement that different ads would get. Oh, wow. And the day that we first produced those results and found that they did match almost perfectly actually the levels of engagement we were getting, it was mind-blowing to me.
Oh, yeah.
I was like, you're telling me that this math and this code, this technical work can help us understand humans better and how they'll behave?
Behaviors? Yeah, right.
I literally had a light bulb moment and called my family and was like, these questions I've been wondering about, they intersect here. I have to be doing this. I have to be working on this. I've never seen anything like this before. And literally went back to school, and that first week changed my major. It was like, this is what I'm going to be working on. It was mind-blowing to me, and a credit to Google's history of open sourcing code and these ecosystems, because otherwise I would have had absolutely no idea that this was something that you could be working on. And it truly was an unbelievable light bulb moment for me.
Yeah, I can see it in your face. Like you just like, I'm like there with you. Like, I'm excited too.
Oh,
that's incredible. So
thank you.
So you then go to college, you change your major. So where does the intersection of large language models and sort of language come into play? So you change, you go into computer science with a focus on machine learning.
Yeah.
And so where does the language component come in?
Yeah, that's a great question. So at Stanford, the artificial intelligence course load is essentially requires or very heavily recommends that you try out lots of different applications for artificial intelligence. So you do a little bit of computer vision, you do a little bit of language work, you do a little bit of reinforcement learning, which at the time was largely used as an application for working on video games and sort of that type of problem. So I took a lot of classes in a lot of different applications for AI. So the class that I took on
Mm-hmm.
language applications, it was sort of another light bulb moment for me. And
explain a little bit what that is, like the context of like learning like language component in machine learning.
Yeah. The class focused on sort of the history of the types of problems that we tried to solve in sort of ML for language. Because our techniques changed and developed as the problems that we were working on grew in scope. But
that's like, sorry, that's sort of when I think about machine learning and language, the most obvious thing I think about is like Translate, Google Translate, right? Where you're inputting a word, and it's the behind the scenes is a machine learning model has access to all of this data, this translation data, that then can match the word hello in English and translate it into French, for example.
Yeah.
Right? So that's sort of what I think of as like a direct product application of language and machine learning.
Totally. So that was one of the first major categories of language applications for machine learning, but it actually started even smaller than that. Once we got to translation, that was a huge breakthrough moment in ML for language. But it started even smaller than that with this problem, which is code obviously functions in zeros and ones,
right,
and it's
the binary,
quantized.
Right.
Yeah. So we operate in numbers, in code. So language is very tricky in that it's very difficult to translate, for example, a single word into what should that be in zeros and ones?
Right.
It's not obvious. And so it started as, how do we essentially encode words in a programming language so that the way we encode them is meaningful? We could assign every word in existence a number, 0, 1, 2, 3.
Right.
But
That would
that's
take
not,
forever.
but it would take forever, and we would lose a lot of important things about language.
Right.
It's good to know that pretty is a word that's similar to beautiful. We want to encapsulate the meaning of words in some way. So one of the first major problems that we had to work on was, how do we encode the meaning of words in code? And this is actually a problem that was largely solved by Google and by an algorithm called Word2Vec, which was then open sourced and made available to the entire ML community. And it's essentially an algorithm that takes in a word and outputs, a series of numbers that says, this is the value of this word. And
This is like what the computer understands. it to
exactly.
be.
And
Yeah.
so computers can understand that series of numbers and tell you lots of interesting things about the meaning of words, about synonyms and antonyms. So it started, this class started with this question: how do we encapsulate the meaning of words so that a computer understands them
And understands the deeper meaning of it.
and understands how
Yeah.
words are related to each other, what order you might want to put words in, the grammar of different words. And then, so we studied the Word2Vec algorithm from Google, which, thank goodness they open sourced it, because that then is the foundation that all other language algorithms are based on for machine learning. So it starts with this very specific problem. And once you understand words, then you're able to build up to harder and harder problems like translation. So now that we know what these words mean, we can flip back and forth between words in different languages and put them together in interesting ways. And then once we can sort of do translation, maybe we can just start generating text in meaningful ways. We can have a chatbot that can give you a response to sort of the prompt that you've given the chatbot. We can have AI that starts writing stories, and we can start stringing together words in interesting ways that are meaningful to the humans reading them. But it all sort of started with Word2Vec as one of the major breakthroughs that enabled then future deep learning technologies to be developed.
That's fascinating.
Yeah. And to be fair, there was decades of research before Word2Vec leading up to that breakthrough moment. So starting in the 50s.
Yeah.
But I point to that as one pivotal moment for when we start seeing machine learning work for language and for text.
Wow, that's fascinating. Yeah, I mean, you can, I think, with technology, it's like, what is the starting point? Well, they're really, where do you want to go?
Farther and farther
exactly,
back. Yeah,
exactly. So you said that there was this light bulb moment.
Yes.
So take us to that. Take us to that moment for story number 2.
I think, yes. Thank you. I forgot that was the original question. In this class, we're learning about what is the meaning of different words. How can we make a computer understand the richness of language? And that exercise felt very similar to theater for me, where you read a script and you just have these plain words on a page, and you're able to extrapolate all of these interesting things about a particular character, how characters interact with each other, familial units, communities of whatever the script is. And so it felt I felt like I understood how much rich information there was in just pure basic text, and that there's so much that we can understand from this form of data and this source of data
And play with.
And there's just so much richness there, that the idea of trying to teach a computer to understand all of the nuances that we understand from text, I thought that was a fascinating problem and such a hard problem. We understand so many interesting things about the subtext and the emotional undertones of text that it seems like it should be almost impossible to be able to teach a computer that. It feels miraculous that humans know how to do that. So part of it was, marveling at humans' ability to do that and being fascinated by the idea that we could teach a computer to do some of that work as well.
Which begs the question of really reflecting on ourselves.
Yeah.
And how we do it too. So it's like you're bringing up all of these additional questions because you're using machine learning and sort of machines as a mirror to ourselves and thinking about intentionally how we do things to try to replicate it.
Absolutely.
Which is fascinating.
I think there's a lot of interesting parallels and a lot that we can learn from neuroscience and human development. How do we learn language? It's such an interesting process. So I think there's a lot that we can learn from humans about how to do this well.
Yes, definitely. Yes, I keep interrupting your light bulb moment. Okay. So,
no, but that was the light bulb moment, is that I really was like, there's so much here. There's so much of humanity is encapsulated in what we write down. And we have centuries of amazing writers and poets who have done the incredible work of writing down the experience of humanity through text. And so it just seems so rich, and it seems there was this light bulb moment of, look at all of this that we have encapsulated in text. Mm-hmm. And look at how little we understand right now in technology. We have so far to go to catch up to humans in this way. So that was a light bulb moment of wondering if it would ever be possible to understand text the way that humans do, and to teach a computer to do that. So I just thought that sounded unbelievably hard. Yeah. And so interesting to try.
Yeah.
So I just kept going with that.
Fascinating, the journey in hindsight of how far we have come.
Yeah.
So
absolutely.
So let's take us on that journey. So you that was sort of where you started your understanding and your research into large language models and language learning, machine language learning specifically, and you then got hired at Google specifically because of I'm guessing the skill set that you and this research that you brought.
I think that if the Kathleen that was playing around with TensorFlow at that startup many years ago could see the technologies that we're dealing with today, I can't even begin to describe how unbelievable it is, how far this technology has come in such a short amount of time. It's such an exciting moment. It's such an exciting moment. And to be working on the open version of that has been such an exciting experience, because the one thing that I should mention of sort of pre-Google and sort of my early years at Google is my thesis and my work in school was almost entirely based on Google's open source ecosystem. We're relying on Word2Vec, BERT, the Transformer, T5. Google has such a long history of incredible innovations that were all released publicly. And
open source means that it's released, the code is released, people can play with it, they can test it, they can use it, they can build on it, they can hack it, they can do all these things.
Exactly. And I think the key part of that you just mentioned is they can build on it.
Right.
And so much of the last, especially 5 years of technological developments have been based on the Transformer, which was publicly released by Google and enabled a whole new wave of research. The technologies that we're seeing today are directly, we're directly based on
and influenced
by Google's open work. And so I was the very lucky recipient of that, in that so much of my own research relied on the fact that Google had released so many incredible tools for researchers to develop on top of. So when I came to Google, I About 2 years ago, I joined a team in Google Brain called the T5 team, which was responsible for developing T5, MT5, T5X, Flan T5, a huge suites of tools and code and models that were 100% of it was publicly released.
That's a large language model.
That's a large language model. That's a large language model. So at the time, it was the biggest large language model ever built, and it was publicly released. And then Palm was a successor to T5, Palm 2, and now Gemini. So I joined this team of very brilliant, wonderful researchers who all were very passionate about open source. They had done this incredible work and released it and spent many years making sure that the open source community was supported in being able to develop on top of these models. And back in October, it must be 2022 now, we had a team summit where we basically had 20 researchers come together, and we spent an entire day talking about how the technology had developed so rapidly that the open source community was at risk of falling behind internal development because technology was moving so fast and there hadn't been a public release of state-of-the-art technology in a while. From Google.
Yeah.
And so we had been talking about how impactful open source was. And we had this, this great day of conversations. And I left this day and was like, okay, we can do this. Yeah. We should do this. And I said, okay. And I luckily had an incredible manager, Noah Fidel, who I said, I think we should be doing this. I think I should stop what I'm working on and work on this 100% of my time. And he said, great, do it.
Wow.
Yeah, so I was a junior engineer at this point. I was just a software engineer, no senior, no nothing about it. And just thought, Google has so many great tools. We can build this. We have so many incredible resources in terms of the knowledge and expertise needed to build this in Google Brain. Let's do it. And so I just
did it.
started doing it. And I wrote a bunch of docs about how important open ML development is, and circulated it amongst my team. And luckily, everywhere I turned, everybody who I asked for feedback or help or support, everyone said, yes, open source is important. Let's do this. I'll join you. And so everywhere we turned, people kept joining the effort.
Wow.
So it grew to a team of about 20 core contributors of research scientists and research engineers and software engineers from Google Brain developing the next wave of open models. And
based off of Gemini.
Well, at some point during this process of starting to build our technology, Brain and DeepMind merged.
Right.
And Gemini was born. And basically we turned to Gemini and said, this is going to be the next wave of technology. I wonder if people here care about, open models as much as we do. And again, everywhere we turned and everybody we talked to, including the Gemini leads, the Gemini engineers on the ground, said, yes, open source is so important. So if we're going to build the best models in existence, they need to be open as well. We need to have an open component to it. So we are releasing a small, we call it the 2 billion parameter model, that can be used on device, can be used on CPU, and sort of a single developer workstation. We'll also be releasing a larger model, the 7 billion parameter model, that can be used on GPU and TPU in cloud. You can find them in Hugging Face, you can find them on cloud, JAX, PyTorch, TensorFlow. Anywhere models are available, you should be able to find these models. And our hope is that it will enable people to do a new wave of research and help us develop the next frontier of AI and of large language models.
This is very exciting and also a very good segue because there is sort of this AI spectrum, which I feel like has been growing, of sort of folks who on one end are very concerned about, like Jeffrey Hinton even, is openly talks about how concerned he is about the impacts of this technology. And then you have folks like Sam Altman, for example, who are very, very pro and sort of an accelerist and want to move this forward. And then you have folks like Dr. Fei-Fei Li, who's kind of is a sort of human-centered AI who's kind of in the middle, who believes very strongly in the power of it, but who also does see the concerns. And so I would love to know, I guess, your personal stance on where you fall within that spectrum, and then also maybe talk about sort of the future and the implications of open sourcing too. So let's start first with the sort of this. I guess there is a concern around this technology. There's excitement and concern, and how do you view this spectrum, and you personally, how do you feel about it?
Yeah, absolutely. I think I definitely fall somewhere in the middle there. I think the impact of this technology is going to be huge. We're already seeing it shift the way people work, the way people interact with the internet.
Right.
We're seeing already massive impacts of this technology. And so that's a double-edged sword. So I think we have to be very aware that if there's going to be a huge impact, we need to avoid having a huge bad impact. We don't want to harm people. We don't want to hurt economies, societies, institutions. So I think because of how large the impact is, we have to be aware of the risks that we face so that we don't go into any of this technological development blindly.
Right.
We need to actively avoid any of these sort of very risky outcomes.
And so did you go into training into this concept of open source with that mindset already set in place?
Absolutely. Yes, for sure. This is something that I think we talk about all the time at Google, about how to build safely and responsibly. So this is something that we are always talking about, always thinking about from the very get-go, back when it was just me and Noah and Tress. We were having this conversation and writing these documents about safety and responsibility from day one.
Right. And for anybody listening who wants to understand more about responsible AI, we did interview Tulsi Doshi as well.
Great.
Who
I'm so happy to hear that.
In last season. So she and we'll link the episode, but
Great.
she's in season 2 and she talks a lot about the context of and the history of responsible AI. So just throwing that on there for context.
Yes, absolutely. A great resource. Would highly recommend people take a look at that episode. So yeah, this is something that we thought about from the very beginning. So I think we have to be aware of the risks that we face. But I also think that the potential benefits of this technology are unbelievable. We're already seeing huge positive impacts from this technology.
Especially in health.
Yeah, I was going to say, especially in healthcare, of people being treated in a safer way, people being diagnosed faster. So I'm somebody who wants to be aware of the risks, but also understands that there's huge hope for this technology that I want to make sure that we are able to capitalize on and that we can deliver these massive benefits universally.
Well, you yourself have benefited.
Yes.
Right? You were saying, your whole work, your whole career in many ways was built off of the fact that this technology was open source. I mean, it's part of research. It's part of advancement.
Being as transparent as we can be about the techniques we use to develop these models allows us to do really rigorous science. It allows us to really thoroughly evaluate and analyze these models, to pinpoint the places where they fail, to provide ecosystems where we can develop better, safer techniques. In particular, I think we've seen the field of privacy research for ML has largely been fueled by open checkpoints, by open ecosystems. And that's a hugely important area for future research investment.
Right.
So I think I think we'll continue to see that by opening these checkpoints. We're being as transparent as possible about how we build these things, and we grant that power to a much broader audience so that we can make sure that this technology is serving a broad audience. We don't just limit the benefits to a small group, and we don't limit the risks to a small group. We want to make sure that people are universally benefiting from this technology. So I think by enabling rigorous scientific evaluation and development of this technology, we'll only continue to build safer and more responsible models.
Yes, I believe that too. I think that I believe that too, and I'm definitely an optimist, and I'm also a big optimist and a believer in society at large. That because I think one of the risks is you release this technology, it's made as safe as possible, but there's no control over how people are going to use them.
Absolutely,
right, and that is one of the risks. And I mean that goes without saying for any piece of technology that you release, but because these models in many ways are so powerful and there's a different dynamic to them than there has been, I think, with other technology. That is just one of the things I think about is people using these for their own gain or for various reasons. And so
I agree with you. I think, I'm an optimist about this technology, but it's not enough to just be optimistic that people will use it well.
Right.
And so we've worked incredibly hard to make sure that we're accounting for the ways that this might be misused, but we're making sure to assess the different risks associated with opening these models. So while I'm optimistic, it's not enough to just be optimistic. We have to put in the work to make sure that we're building safe models, we're building responsible models, and that as much as we can, we're minimizing any risk that might occur by opening these models up publicly. And of course, Google has a very thorough responsibility and safety process. So we've, these...
Well, and because of its history too. I mean...
Exactly. So we've gone through sort of as much red teaming, which is, hacking the models to see if they break, and if they break, how we can fix them. So we're very fortunate that Google has such clear processes here and so many people working on safety and responsibility that we've been able to bring them on to the development of these models.
Yeah, that's fantastic. And ultimately, I also trust that humanity will put things in place. Like one of the examples I keep coming back to is, when we developed the car, we had to develop road signs and the car kept on being reiterated upon, and seatbelts were implemented and airbags were implemented. So from a tech perspective, that kept on being iterated for safety. But then society had to sort of also put in place, like I said, traffic lights and stop signs. And so I'm an optimist in the sense that I also believe that society will come together to help us in that process too. I think it's just so new. So we're sort of still figuring it out. So speaking of the future, we'll close out with my last question is, I think, what's next for you, Kathleen, and where are you, what are you excited about? Is there like a next big thing for you? Or is it a secret?
That's such a good question. There's about 1 million things that I'm excited about. I can't believe how far this technology has come, and still how much farther we have to go. There's so much work in front of us. As for what's next for me specifically, that's a secret for another podcast episode in the future.
Excellent.
TBD will hopefully have updates there to publicly announce at some point in the future.
Great.
Yeah.
Oh, I'm so excited to follow your journey.
Thank
it was
you.
an honor to have you on the
Thank
podcast
you.
and share your story. What an incredible story. What an incredible story. And I enjoyed. Thank you for sharing it with us and for also helping us learn more about these open models that Google is releasing, and excited for the future and to follow your story.
Thank you. Well, it was absolutely my pleasure, and I have to say thank you to you all for, really spreading the word and communicating about this technology in such an effective way. I'm excited for people to learn more about the work that we're doing and more about this technology. So thanks for all of your great episodes.
Who's building with it too. So
absolutely. I can't wait to see what people build with it. I'm so excited.
The future's bright.
The future's bright.
If you would like to learn more about our conversation or our guests, check out the links below. Please subscribe, and if you're feeling extra generous, give us a 5-star rating. We would love to hear from you, so leave us a comment. We'll read every one. Until next time, thank you for listening.